this video we're going to go over percentage yield calculations. So this is a percentage of the actual yield compared to the theoretical yield. In chemical reactions you may not always get the theoretical yield. In fact it's basically impossible to get it for a number of reasons. This may be because the reaction is incomplete, there's losses during the experiment like carbon dioxide gas given off, or you have unwanted side reactions which use the products as reactants. So to calculate percentage yield we have actual yield divided by theoretical yield. And by yield, in calculations we mostly mean mass, just because it's easier to weigh at the end of a reaction to calculate the yield. So if we do some examples, 23 grams of calcium carbonate decomposes and 9.66 grams of calcium oxide is formed. What is the percentage yield? So we have the equation here. Calcium carbonate decomposes to calcium oxide and carbon dioxide. So we are told that 23 grams of calcium carbonate decomposes and forms 9.66 grams. So 9.66 grams is the actual yield. We need to calculate the theoretical yield. So given 23 grams of calcium carbonate, we need to find what is the maximum amount of theoretical calcium oxide that could have been produced. So if we write out our table, we have calcium carbonate and calcium oxide. I've done a previous video on stoichiometric calculations which involves this. So we need to include moles, mass, MR, and the ratio. So as mentioned in previous videos, the moles can be calculated like this. So we can fill in our table. So we have mass. We were given 23 grams. And we want to work the theoretical yield of calcium oxide. The MRs can be calculated here. These are found on the periodic table. These are atomic masses. So the MR of calcium carbonate is 40.1 plus 12 for carbon and plus 3 multiplied by 16 for the oxygen. So the MR is 100.1. For calcium oxide we have 40.1 plus oxygen, so 16, which is 56.1. The ratio is the stoichiometric ratio in this equation. So we can quickly check that it balances. So we have 1 calcium, 1 carbon, 1 carbon, 3 oxygen, 1, 2, 3, 3 oxygen. So this equation is balanced. So as we can see, calcium carbonate and calcium oxide are in a 1-to-1 ratio. The stoichiometric coefficients are equal. So now we need to work out the moles of calcium carbonate. Moles equals mass over MR. So mass divided by MR gives you 0.2298. Because we're in a 1-to-1 ratio, 0.2298 here. And then we need to calculate the theoretical yield or mass of calcium oxide. Mass is moles times MR. Moles times MR, 56.1. So theoretically, this reaction could have formed 12.89 grams of calcium oxide. So this is the theoretical yield. So to calculate our percentage yield, as shown up here, it is actual yield divided by theoretical multiplied by 100. So you have 9.66 divided by answer. So our percentage yield is 74.94%. So that means 74.94% of the calcium oxide that could have been produced was produced. So if we do one more example, 5 kilograms of methane is provided in a combustion reaction. The combustion is complete and the percentage yield was 64. Calculate the actual yield of water. So this means that 64% of the theoretical yield was produced, right? Because for our equation, we have 64 equals actual yield divided by theoretical yield multiplied by 100. So it wants us to calculate this. And we can calculate theoretical yield because we know how much we've given as a reactant. So if we look at this equation, we've got methane, oxygen, carbon dioxide and water. So if we draw our table, we have methane and we are trying to calculate the yield of water. So water would be on the other column. We would have moles, mass, MR and the ratio. Before we fill out our table, we can check that our equation balances. So we have 1 carbon, 4 hydrogen, 2 times 2 is 4 hydrogen. Then we have 4 oxygen, and then we have 2 oxygen here and 2 oxygen here. So everything balances. So if we start to fill in our table, for methane we were given 5 kilograms, so that's 5,000 grams. The MR, so we can calculate it using the periodic table. So the MR for carbon is 12 and the MR for hydrogen is 1. So 12 plus 4 is a 16. And for water we have 2 plus 16, so 18. So once we've done that, we can add in our ratios. The ratio of methane to water, 1 to 2. And we need to calculate the moles. So if we use the equation we used before, moles equals mass over MR. So moles of methane is the mass over MR, 16. So 312.5 moles. Because the ratio is 1 to 2, we multiply this by 2 to get the moles of water, which is 625. So the mass of water is moles times MR. So mass. So 625 multiplied by 18. So we needed 11,250 grams of water, theoretically, that were produced from this reaction. So because the percentage yield was 64%, so we have 64 here, we can rearrange now that we know the theoretical yield. So this means 64 equals X, which is the actual yield, what we need to calculate. 1250 multiplied by 100. So if we rearrange to find X, so we do 64, divide both sides by 100, so 0.64 equals X divided by 11250, and then multiply both sides by 11,250. X, our actual yield, is 7,200 grams. So 7,200 grams of water was yielded from this equation. Usually in water we would measure in milliliters, so to convert to milliliters we would take into account the density, as density equals mass over volume. So that's how you do percentage yield calculations.